All right, let's go ahead and talk about the next really important idea that we've got when we're talking about the distribution of data. There are several qualities that are very important for us to understand. Okay, first is the shape. Okay, so these ideas are all the important things that affect and important characteristics that we have to know about the data so we can compare data, so we can understand its behavior. And so first and foremost is shape. And so then we'll go into these each in turn in detail in a moment. The other thing is, of course, we want to talk about if there are outliers. There are two sets of outlier rules that we know. One of them, of course, is based on the IQR rule. We've done that with our box plots. But this new one, now that we know standard deviation, is a standard deviation outlier rule. This is more common than the IQR outlier rule because in real data, we're typically using that standard deviation more than those box plot IQR stuff. So that's actually the more common outlier rule. All right, then center. And we've already talked about this whenever we were doing the last assignment, knowing how outliers affect center and spread tells us if we should be using the mean or the median for the center, and if we should be using the IQR or the standard deviation as a good descriptor for our spread. All right, so those are the ideas and those are the items that we need to use to describe the distribution, describe the data. Now, we also need to make sure that we are specific. So if I say I want to tell you about the center, where the data is centrally located, then I'll be telling you which one I'm using, mean or median, and I'll be telling you the number value of that mean or median, okay? I'll be telling you about the spread I'm going to use, whether I choose IQR or standard deviation, and then I'll tell you the specific number of that spread. And so then we'll also talk about in this video how you know which one to use, mean or median or standard deviation IQR. So here we go. Shape, outlier, center, and spread. So you're going to describe the distribution with your socks, okay? Shape and outlier, center and spread. So let's start with our shape. All right. For main shapes, we've got this uniform or some uniform. So uniform is where every piece of data or every set of categories across here, the numerical categories, are about the same. They're uniform. They're like everybody's wearing the same uniform. They're about the same. Okay. Real data isn't going to be perfectly the same. There will be a little bit of differences, but not perfectly the same, but somewhat uniform. All right. Then we need to know if the data is skewed left or skewed to the right. So these are common confused items. So I've got a way to help you remember. If the data is skewed to the right, then I want you to think about looking down at your feet. That's why I have this weird picture of feet showing up here. You're going to look down at your feet. And if your feet are, like your toes are going like this, that is your right foot. So that is how a skewed right distribution is. And those have certain qualities. There's going to be certain things that we know skewed right distributions have. That's why it's important to identify the shape. All right, then if you look down and you see your left foot and you're looking down at your foot and you see your left foot, that is a skewed left shape. All right. And then I think you can tell the basic one that we've dealt with a lot and that our typical bell curves do, symmetrical. Okay. Then we also want to talk about how many modes. How many modes. And I don't think I even wrote that on there. But a mode is where the most is occurring. This does not have a mode. It's uniform. Okay. And it is symmetrical, okay? This one here has one mode. It is unimodal, okay? Unimodal. This is also unimodal. Mode is the most. It has one peak. Unimodal. But here you can see an example of a bimodal distribution because it has two main peaks of areas. Now, keep in mind that real data isn't perfect, and so I really even hesitate to have this picture on here. This is a little misleading because I don't want to say just because one bar peaks up there, that's a whole nother mode. When you're describing an additional mode, it's really because there's some kind of subset happening. See here, this is really two kind of clusters of data. So that's telling me something like, hey, maybe, this is all the heights of children. Okay. And so then I had maybe more children in my sample. And this is the distribution of the heights of the adults in an elementary school. So see, so a bimodal distribution really isn't just, oh, one little old bar is higher. No, it's more informational about, hey, there's really kind of two subsets of situations here. This may be the heights of the elementary students. So see, they're kind of distributed around this size. And this is the heights of another group in the school, maybe the adults. Okay. So that's your bimodal. Okay. You can also have, once after you go unimodal, bimodal, then past that, if there's several subsets, then you're going to say this is multimodal. Okay? Multimodal, that's what you go to. So what I want you to do is come on down here to the bottom of this page here and take a moment to identify these shapes. Identify them with symmetric or unimodal, uniform, symmetric, okay. So let me say that a little better. If you think about it this way, we've got some types of modes, okay? So do we have no modes? You know what has no modes? Something that's uniform, okay? Do we have one mode? Do we have two modes? Or do we just say multimodal? Okay, so that's your choice on how many modes there are. Then we do the shape. So then the shape, okay, and so then that's going to be the symmetric, skewed left, and skewed right. All right. So identify those down here below. Take a moment to do that, and then we'll look at the answers. All right. So let's check and see how you did. Okay. So let me get my answer key back up here. All right. This one is unimodal and it's symmetric. Here we have unimodal. Those are both unimodal, and this is like your left foot, so that's skewed left. This is like your right foot, so it's skewed right. Now, down here, see, this isn't perfect. It's not perfect all the way straight across, but it's pretty close to being perfect all the way straight across. So that's uniform, okay? There's not any real clear mode. Uniform, somewhat symmetric, I guess. Okay, here, this is going to be bimodal. This is clear to me. I kind of have two subsets of something happening here. So that's also, I would probably tend to say that I've kind of got this going. See how this is a little higher and then this one's a little lower. So I'd probably even classify this as overall kind of skewed to the right. That one's kind of, some of these are debatable, and real data is going to be that way. All right, this one is, should I say skewed left because this one's higher? I don't know, somewhat, but I do know it's multimodal. And there's just not a ton of difference here, I guess, especially with this and this. So somewhat symmetric. Somewhat. See? Not perfectly symmetric, okay? Real data is hard to describe in perfectness and absolutes, like with the Siths or anyway, Star Wars thing. Okay, outliers. So we know there's outliers. There are two different rules for the outliers. You already know this one here. You know the box plot outlier rules. And then you know that when you have data, okay, this is important, data above the upper fence or data below the lower fence is an outlier. Okay, so data above the upper fence or data below the lower fence is an outlier. All right, you're familiar with that IQR rule. Here's the new one. So with our standard deviations, now we're going to identify what's unusual with standard deviations. So we'll end up talking in a minute about how we really should not be using mean and standard deviation as a descriptor unless it's somewhat symmetric, okay? Then, when that happens, here's the rule. The mean minus 2 standard deviations, so this is the lower fence. Mean minus 2 standard deviations is the lower fence. Here's the mean. Minus 2 of the standard deviations, okay? The upper fence is the mean plus 2 standard deviations. So let's discuss, where are the outliers? Remember, data above the upper fence or below the lower fence are the outliers. Data above the upper fence or below the lower fence is an outlier. And of course, here we have something just unusual out there. That's your outlier. Okay, now, measures of center. So we've kind of been discussing this as we did our lesson the past 2 days when we talked standard deviation and such. And so we know the two centers that we have to be familiar with are the mean, which is add them all up and divide by how many there are, okay? The mean, you know that mean. And then the median, put them all in order and find the one in the middle. All right, so those are our two main measures of center, telling me where the data is centrally located, okay? And then here's our two main indicators of spread. How spread out this data is. There's two ways to indicate that. Either that middle 50%, okay, or what we just learned with that standard deviation, the average distance from the mean, that standard deviation. Now, let's kind of pair these up because there's ones that go together. If they're in the same family. So if median, and I hate that they kind of are mixed up here. So in fact, I'm going to show this page all in one thing here. So what you need to know, one of the things you need to know is that median, remember when we did median, we also used it with the 5-number summary with our interquartile range. So one thing to be aware of, median and IQR go together. If you're going to tell me about the median, then the spread that's appropriate to use is your IQR. Okay? Median and IQR, they're part of the same family. Okay? And likewise, if we end up having information about the average, then the spread that should go along with it is that average distance from the mean. So mean should pair nicely with the spread of the standard deviation. Okay. So the next idea is, how do you know which one of these measures should you choose to use? So this is a big deal. How do you know? Okay, so let me write that out here. How do you know? Should you use the median and the IQR, or should you use the mean and the standard deviation? Okay, how do you know which one to choose to use? Well, the way you know is based on the shape. The shape is the answer. The shape tells you which to use. The reason that the shape tells you which one to use is because of what we discovered and talked about in our recent lesson. Do you remember when we did our problem with the Subaru cars? When we had the cars and they were all pretty good, close to each other, we had our, in fact, I may go ahead and pull that out here and let me back up to that real quick. So remember that whenever we had this situation here, where we had all of our data pretty nicely located, we had a mean of 19.6 and the median was about the same at 19. The IQR was 4, the standard deviation ended up being 2.88. But when that outlier was introduced, when that measure of 23 was now 44, and we had an outlier, the mean was affected and the median was not. The standard deviation was affected and the IQR was not. That is why we choose certain measures to use. So the shape, because if you have skew or if you have outliers, then you need to choose to use the median and the IQR because they are not affected by skew. They are not affected by outliers. Super important. The last final important idea is that. How do you know which one to choose to use? Well, here it is. I did make a little song about it. I think I actually have it on the previous page. Here it is. If you have skew, then you must choose to use median and IQR. Ooh, symmetry. Use standard deviation and mean. Okay? So, and I'll play you the actual real video of that here in a minute. But if you have skew, if you have outliers, then median and IQR are the measures to choose to use because they are resistant to that. And that's what this song here is telling us. It's a little bit slower, but it's kind of hilarious because it's so dramatic. And it says, let's see, all I know is that I need resistance. When there is skew, when there's outliers, all I know is that I need resistance. The measure of center that is resistant to the skew. The measure of center that is not affected by the skew. The measure of spread that is resistant to. So the measure of spread that is not affected by the outliers are the measures that I should choose to use. I guess that I should choose then. So the ones not affected are interquartile range and median. Okay? So if you have skew, then you must choose to use median and IQR. Oh, symmetry. Use standard deviation and mean. Okay. That is shape, that is outliers, that is center, and that is spread. Now, just a couple other quick things. And so let's take a look at that. Here we go. You can see here. So here's the last final concept we got going on here. You can see here with our measures of center that their values, as we just talked about, their values are affected by the shape because, the median is resistant, the mean is not. Okay? So, you need to know how are they affected? What is this shape doing? How does this shape affect the relationship between the mean and the median? So let's take a look. One simple way we can see is that if you have these upper outliers, and you know this, if you make a higher grade, then what's that going to do to your average? A higher grade is going to pull your mean, your average up. So it's going to pull up your average. Likewise, if you got a 0, that's a low grade, a lower outlier. What does that do to your grade? It's going to pull your grade down, your average down. So in summary, what we see, and I'm going to pull this over here so I can do it without the answers already in. So what I see down here is that if I have a shape that is skewed to the left, then we're going to use inequalities that are pointing to the left, the less than signs. We're going to write our measures of center in order from in alphabetical order. Mean, median, mode. Do you see how I wrote them every time? Mean, median, mode. Mean, median, mode. That's how you're going to write it every time. Then you're going to put your inequalities in. If it is skewed to the left, then the less than sign is your inequality. So what does that tell me? If it is skewed to the left, the mean is smaller than the median. And the median is smaller than that mode. Okay, now, what's happening if the data is somewhat symmetric? Well, hopefully you can see that if the data is somewhat symmetric, then the mean and the median are actually about in the same place. So if they are symmetric, then they're about equal. The mean and the median are about the same. Okay, they're about the same. So the final idea is that if your data is skewed to the right, then look at there. You're going to point to the right. So our mean is greater than the median, which is greater than the mode. So there you go. So there is that final idea of how to understand the relationship between shape and those measures of center. So later, we're going to find out, I could just look at these two numbers. I could look at these two numbers, the mean and the median, and then I could tell you the shape based on the relationship between those two numbers. So if I had an average that was much higher than the median, then, I know that data is skewed to the right. Okay? Or if the mean and the median are about the same, hey, then I know the data is about symmetric. Okay? So that's the last final big deal. So, in summary, we have discussed shape, the modes, and symmetric, skewed left, skewed right. Shape, outliers. Okay, shape. Outliers, 2 different rules. Your box plot outlier rules, which you know already, and your normal model or your symmetric ones with the mean plus or minus 2 standard deviations. Okay. Then center. Your 2 centers are mean and median. And your spread, your 2 measures of variability, your IQR, and your standard deviation. Now, Which of those should you choose to use? Well, that depends. Do you have skew? Do you have outliers? If you have skew, then you must choose to use median and IQR. Ooh, symmetry. Use standard deviation and mean. Okay? And why is that? Because if I have skew, if there are outliers, then I know is that I need resistance. So the measure of center that is resistant to the skew, the measure of spread that is resistant is the interquartile range. The IQR and median are the ones that are resistant. Okay. And then that relationship between shape and those summary statistics. Okay, so there's our summary. Now, there is this one last next page of going over describing the distribution. But I think I'm going to hold off on this page and start it tomorrow, right before you do your assignment, because I think that would be a good way to review our notes of the day and then talk about how you look at this information and write up the description of this distribution. So we'll do that tomorrow right before we do our assignment that goes along with that skill. Okay? So hopefully you now can describe a distribution. Tomorrow we'll understand how to describe a distribution with our SOCs: shape, outlier, center, and spread.